Students, welcome to Alpha C Learning Program Mathematics class. In previous session, we have discussed here about two tangents. Okay, that means two tangents can be drawn from a point outside a parabola to here y square is 4ax or any kind of here parabola we have observed. Now let us observe here some problems how to solve from numerical values. This is find equations of tangents drawn to a parabola from the point 1 comma minus 1. Students, observe clearly here, this is very important. Okay, so preposition we call, so if it is given as at, the formula is different, from, the formula is different. Same problem if it is given at the point 1 comma minus 1, then we would have used directly the formula S1 equal to 0. S1 is 0, you know how to write that S1 is 0 value. Simply we can write if the problem is given as at the point. But here it is given from the point. From the point means actually here the point is not on the parabola. If you substitute here, this is 1 and minus 3. That is here minus 2 plus 2 0. And if it goes to that side, it is plus 1 greater than 0. Because the standard form is x square equal to. And therefore here the point is falling outside the parabola. When the point is outside parabola, then we know here two tangents can be drawn. Then how to find here those two tangent equations when it is given as from? If it is standard form, we would have used the formula directly, that is y square is 4ax suppose, and the point is here some x1 comma y1, then we can make use of the formula m square x1 minus my1 plus a equal to 0. This formula you can observe where m is here, the slope of the two tangents can be obtained quadratic. Okay, and but here it is not the standard form given. Suppose x square is 4ay also we can do, but here this is not the standard form given. The parabola here axis is parallel to y axis. This kind of parabola, then how to find here the tangent equations? Two methods are there. Let us do both the methods. One of the methods, let us take here y equal to mx plus c be the tangent. Okay, let y equal to mx plus c equal to tangent, and now this tangent actually passing through 1 minus 1. The point is not on the parabola, but the point they said here tangents are drawn from the point, implies the point 1 minus 1 is on the line. That implies here if you substitute this line passing through here, which point here 1 comma minus 1. Okay, therefore here we substitute the point as 1 minus 1, and thereby this is minus 1 is equal to m plus c. That implies c equal to minus 1 minus m. Then if I substitute here, it is y equal to mx, and this is minus 1 minus m. Okay, now once you got this value here, we know here if it is tangent to that one, then the discriminant is 0. So we are going to make use of the same concept. Now this is the line we got in only one unknown, and the curve is given as here, parabola is here, y is x square minus 3x plus 2. Then our method is here, simply substitute x value or y value, thereby we can obtain quadratic in x or quadratic in y. So already it is second degree in x, therefore let us substitute y value as it is. That implies mx minus 1 minus m equal to x square minus 3x plus 2. Understand? Now let us take here these two values also the other side, implies x square minus 3x minus mx plus 2 plus 1 plus m equal to 0. That implies you got here x square minus x, if I take common, this is 3 plus m into x, and this is plus 3 plus m is equal to 0. So now here we got a quadratic in x. Now our interest is about tangent. For tangent the discriminant has to be 0. So we take here tangent, therefore for tangent discriminant value is 0. So once discriminant means it is b square, that is 9 plus m square plus 6m. Okay, b square minus 4ac. So it is minus 12 minus 4m. This is equal to 0. So discriminant value we have equated 0 because our interest is on tangent. Now the quadratic you got m square, and this one is here plus 2m. Okay, plus 2m minus 3 equal to 0. Therefore, we can solve here, that is m plus 3 into it is m minus 1 is equal to 0. Then you can obtain here m is minus 3 comma 1. Therefore, slopes of the two tangents are here minus 3 and 1, and these values we substitute here. This is if equation 1 we consider. If we substitute y equal to, what is the value here? Minus 3 if I write, it is minus 3x and 1 minus 1 plus 3. Therefore, it is 2. Okay, so this is minus 1 and minus m if I put here plus 3. Therefore, it is 2. And the other tangent is m equal to 1. M is 1 if I put here. This is y equal to x minus 2. Okay, y equal to x minus 2. If we substitute m is 1 here, it is x minus 2. And now therefore students observe here, these are the two tangent equations from this concept. So what is the method here? Take one of the tangents as here, y is mx plus c, and they said tangents are drawn from the point 1 minus 1. So we substituted here and thereby you got c value. And once you got c value here, we substituted at c here this minus 1 minus m value. Then this line actually, this one actually they are touching, implies we substituted, and thereby you got a quadratic in x, as it is a tangent, discriminant is 0, and hence you got a quadratic in m. If you solve, you got two distinct real values. Okay, that implies two tangents can be drawn, and we substituted here, that is minus 3x and minus 1, this is plus 3. Therefore you got it is 2 and the other tangent. Okay students, so this is one of the methods, and other method also there by using actually the standard relation. Now what is the standard relation? Observe the parabola equation. It is of the form x minus alpha whole square equal to 4a into y minus beta. Okay, so you can choose any method students, whichever you feel comfortable you can choose, but the first method whatever just now we did, you can apply to any kind of parabola, even for oblique parabola also it will be useful. So now suppose if I am taking this equation in the standard form, so y minus 2 first I am writing, and the left hand side if at all you want to write the vertex form, that is x minus 3 by 2 whole square I am using. Okay, thereby it is x square, that is there already, and minus 3x also there, so extra you are having here plus 9 by 4. So that value I am adding here plus 9 by 4. Okay, that implies the equation is x minus 3 by 2 whole square is equal to, it is y and plus 1 divided by 4. Right? Now this is the standard form we got, where here our 4a is how much? 4a is 1. Okay, x minus alpha whole square equal to 4a and into y plus 1 by, this is y minus beta. So this is the standard form students we obtained, and here what is our 4a? It is 1. That implies a is 1 by 4. Implies this equation is simply x square equal to how much it is? Y model. Okay, and what is x value here? It is x minus 3 by 2, and y value is nothing but y plus 1 by 4. Now once we got this value here, then you know if y equal to mx plus c, this is the tangent equation, then for this model the c is nothing but minus am square, which we have observed in previous session. Now what is that a value here? This a is how much? 1 by 4. So minus m square divided by 4. So now I am substituting that value here. Y is mx minus m square divided by 4. Understood? Now once you got this value here, this is our tangent equation. Moreover, it is passing through which value actually? 1 comma minus 1. Then if you substitute, then you can obtain here quadratic in m. So two values for those m you can obtain, and thereby again you can find here tangent equation. So what extra you have to do is here alpha beta you have to add. What is alpha here? 3 by 2, and the other value is minus 1 by 4. Okay, if you add 3 by 2 comma minus 1 by 4, simply you can obtain here that point. You have to add those, substitute here, you can get here 2 values for m. So this is the other method, students, by just changing into this form, and this one is here using our concept. Okay, and next one is the second problem. Observe carefully here. What is the second problem? The second problem is given as here, number of tangents drawn from a point. Okay, number of tangents drawn from a point to a parabola. Now whenever they ask you about number of tangents, you have to check about the position of the point with respect to the parabola. So S11 suppose greater than 0, there exists a number of tangents is 2, and S11 is equal to 0, there exists one and only one tangent. S11 less than 0, no tangent can be drawn. If any parabola you consider here, if point is outside, we have observed 2 tangents can be drawn here, right? And if the point is inside, we cannot draw any tangent. Whereas if point is exactly on the parabola, we can draw here exactly one tangent. Okay, students, so in this way we can take here number of tangents. Now what about here in this question? It is given as parabola 2y square is 9x, or we can write y square equal to 9x divided by 2. Standard form. So let's find here from the point minus 2, minus 3 they asked here. So x1, y1 is here how much? Minus 2, minus 3. Right? Now what is our s, students, here? S is y square minus 9x divided by 2. And now we want to write s11. S11 is y into y1, that is y into minus 2, and minus half of this value, that is 9 by 4 x plus x1, that is x minus 3. Okay, so this is the value we got, and now here this one, sorry, S11 we want to write here. So substitute directly here, that is S11 is how much here? 9, and minus, this is minus into minus plus 18 divided by 2, that is you got here 9, implies this is greater than 0, implies the point is outside, therefore number of tangents is here how much? It is equal to 2. Okay, next one, third problem. Find slopes of 2 tangents drawn from a point, that is 3 by 2 comma 5 given to y square equal to 6x. So what is the parabola, students? Y square equal to 6x given. Okay, what is 4a value here? It is equal to 6. Then a equal to 3 divided by 2. Okay, so this is the value. Now the question is here, from a point 3 by 2 comma 5. So what is our x1, y1, students, here? It is equal to 3 by 2 comma 5. Now what is our formula? Whenever 2 tangents are drawn to any parabola, that means here we are taking standard form, y square equal to 4ax, and this point is here x1 comma y1. Okay, from the point x1 comma y1, if 2 tangents are drawn to a parabola, then slopes can be obtained from the formula m square x1 minus m y1 plus a equal to 0. So this formula, students, you can apply only to the standard form. Understand? Only to standard form you can apply. Now here m square, and what is our x1 value? It is 3 by 2 minus m y1, m into y1 means 5 plus a means here 3 by 2 is equal to 0. That implies 3m square minus 10m plus 3 equal to 0. So now here the question is here, find slopes of 2 tangents. If we solve this quadratic equation, we can obtain easily the 2 slopes. So what are those here? 3m minus 1 into, suppose if I write m minus 3 equal to 0. Okay, so this one 3m square minus m here minus 9m. So this is our value. Then what are slopes, students, here? Those are 1 by 3 comma 3. That means here whenever the equation given as directly standard form, then you can make use of simply this formula. whereas here it is not asked direct form, that means standard form is not there. Therefore we have taken directly y is mx plus c, or you can make use of the concept of translation of axis. Okay students, so easily you can obtain here slopes of the two tangents. And next one is here, fourth problem, they are asking if two tangents are drawn from a point, okay, again it is given from a point, then they are asking about here if alpha is angle between them, then what about tan alpha value, okay. So angle between two tangents, if it is theta, we have derived a formula, tan theta is root s11 by mod of x1 plus a. So again here also standard form is given, and the parabola is y square equal to 4x given, and tangents are here drawn from the point -2 comma -1. Always check how is the point, -2 -1. So here this is 1, and if it comes this side plus 4, okay, 4 into 2 8. So you got here positive value. Now this is suppose alpha, angle between tangents, then the question is tan alpha, and what is the point given here, -2 -1. This is the point. Now students, what is the formula we have derived for the standard form, y square equal to 4ax, and from the point x1 comma y1, if two tangents are drawn and angle between them is suppose alpha, then tan alpha is equal to root of s11 divided by mod of x1 plus a, okay. So this formula we have derived, and earlier suppose this is x square is 4ay, concept is the same, we can write the value. Now what about here, this is s11, s11 means this is our parabola, so s is suppose y square minus 4x, then s11 value is nothing but it is 1 minus 4 into -2, so that one is here 8, and thereby it is 9. So this is our value, and x1 means this is our x1 -2, and next a value in this problem, what is our a here, 4a is 4, a is 1. So a equal to 1 in this problem, and s11, so let us substitute tan alpha equal to numerator root s11 means 3 divided by x1 means -2, and a means the parabola is this one, so it is 1. So that the answer is how much students, it is exactly mod value will be there, so it is 3. If they ask you about acute value, then we take 3. Suppose if they do not mention, then we can write plus or minus. Alpha they said just angle, implies this value is actually plus or minus. If it is alpha acute, it is 3, and if alpha obtuse, the answer is here -3, okay. Next question students, product of slopes of two tangents, okay, product of slopes of two tangents drawn from a point x1 comma y1, that is here 2 comma 3 to the parabola y square equal to 4x, okay. So y square equal to 4x. Now observe again here, this is 9, if I write s11 I am checking, it is 9 minus 8, that is 1 positive, implies the point is falling exactly outside the curve. So this one is our, these are our two tangents, and the point is here 2 comma 3, and now the parabola is how much here, y square is 4x, right. And now they are asking here what is product of slopes of two tangents. Then again students, make use of the formula. What is the formula, m square x1 minus m y1 plus a equal to 0, okay. So in this problem again, a is 1, 4a is 4, and x1 is here 2, y1 is how much here, 3. So m square x1, that is 2m square, and minus m y1, that implies it is 3m, and plus a, that is 1, equal to 0. Now no need of solving everything, the question is what here, product of slopes of two tangents. So m1 m2, product is c by a, that is nothing but here how much, 1 by 2. So in this way students, just basing on our concept, we can do different problems. Suppose the same problem if they asked here x square is 4y, Okay, x square is 4y or x square minus 4x plus 3 equal to y. Like that some problem. In this way if it is given, however we did this model problem, that is taking y is mx plus c and substituting the point. After that the line we substitute in the curve, thereby discriminant 0, and you got a quadratic. From that quadratic we can obtain again product of slopes. So if it is exactly this kind of y square is 4ax is given, then you can make use of this formula directly. Other than this, whatever it is given, just make use of this kind of procedure. So now till now we have observed, students, for one curve, one tangent or two tangents, like that we have observed. Now suppose two curves are given. They may be both are parabolas, or one is parabola and one is circle. Like this here, any kind of two kinds of curves are given. Then what about equations of common tangents? Okay, suppose if I observe the first one, it is y square equal to 4ax. This is y square is 4ax curve, and this one is x square is 4by curve. Okay, so these are the two curves given. And for this curve, what about here? Equation of common tangent. Now if you observe, students, you can observe common tangent can be like this. Okay, so this tangent is nothing but it is common to this parabola as well as this parabola also. So like this here, the question they are asking about, what about here equation of common tangent. Now let us take in the beginning, this is suppose x square is 4by parabola, and this one is here y square is 4ax parabola. Okay, let us take here the common tangent as y equal to mx plus c. Okay, y is mx plus c. Now you know the condition of tangency for this parabola or this one, therefore we can substitute one first and the other one. Now let us take here, let y equal to mx plus c be common tangent. Okay, it is be the common tangent of parabolas. Y square is 4ax and the other one is nothing but x square equal to 4by. Okay, so this is equation of common tangent. Now first let us take here, for y square is 4ax, if it is tangent, okay, for y square is 4ax, y equal to how much it is? C plus we write a divided by m. Okay, so in the place of c we are writing here mx plus c is nothing but a by m. Now this line is again tangent to what actually? To this curve also. Then just we substitute y value here. Okay, so since y equal to mx plus a by m is tangent to 2, okay, it is tangent to 2, even which other curve actually? X square is 4by. That implies now you are substituting in the place of y. So x square equal to 4b and into y means it is mx plus a divided by m. Okay, now if I take all the values on one side, x square minus 4b mx and minus it is 4ab divided by m, right, and this is equal to 0. And now here let us use, students, again these are tangent condition you are using. Whenever you apply tangent condition, immediately we take discriminant as 0. So here we have taken this is tangent to this parabola also, that's why here we are using the condition of tangency implies discriminant is 0. So delta is 0 implies b square, here 16b square m square, and minus 4ac implies what is that value here? Minus 4ac means it is plus 16ab divided by how much? M is equal to 0. Okay, students, so we got here b square means 16b square m square minus 4ac means 16ab divided by m is 0. Now therefore here we can cancel 16 value. If you do simplification, we can obtain the slope values. Okay, so what about here? Those slope values. First I am cancelling here 16, and at the same time b also, b cannot be 0. If b is 0, the parabola x square is 0, which is not the parabola. So b not equal to 0, hence let us divide by here 16b. then we'll obtain bm square. Okay, it is bm square. After that, this one is here a divided by m plus a by m is equal to 0. So in this way, students, we obtain here, as we have cancelled here, which one, 16b we have cancelled, so that you got a by m here, and here it is bm square. And now next value we want to check here, m is our requirement. As m is our requirement, let us take here bm square equal to minus a divided by m. That implies m cube is equal to minus a divided by b. Okay, it is cubic, so nothing to worry. If it is square we cannot take, but it is cubic. So cubic means here we can take here m is equal to minus a to the power of 1 by 3 divided by b power 1 by 3. Other two are imaginary values, only one real value. That's why you got here only one common tangent. Okay. Now once this is m value we got, we substitute in our formula. So what is our formula? Y equal to mx plus a by m. So y is mx plus a by m. Now we are going to substitute this value, so that it is y equal to minus a power 1 by 3 into x divided by b power 1 by 3 plus a, and this value is 1 divided by m. So minus b power 1 by 3 divided by a power 1 by 3. And now students, let us take here b power 1 by 3 as LCM. So here you observe a by a power 1 by 3 means you will get here a to the power of 2 by 3. Now I am taking b power 1 by 3 as LCM. Then you will get here b power 1 by 3 into y is equal to this side minus x a power 1 by 3. And next value here it is plus a to the power of 2 by 3, one b value you got here. So finally you got this value as minus a to the power of 2 by 3 and b to the power of 2 by 3 is 0. Okay. Now let us write all values on one side. Then it is nothing but here x into a power 1 by 3 plus y into b power 1 by 3 plus a to the power of 2 by 3 into b to the power of 2 by 3 equal to 0. So this is formula for equation of common tangent of y square is 4ax as well as x square equal to 4by. So you can remember this one as formula, because whenever they asked, suppose it is y square is 16x and x square is some 8y, okay, then directly you could substitute AB values here, and thereby you can obtain the equation of common tangent, one of the important formulae. Now let us observe the second problem. Here both are parabolas, whereas here one is parabola and the other one is circle. Okay, so what is here equation of circle? X square plus y square is 2a square. That means center of the circle is nothing but here origin. So here center is nothing but origin. Like this, here we are considering the circle, and the other one parabola whose vertex is again origin. So now this is our parabola. Okay students. Now the question is, what is equation of common tangent? So if you extend like this here, this is one common tangent you can observe, and this side again another common tangent we can observe. Okay, so here by diagram we can say here there are two kinds of common tangents. So this is one and this is other. This one is a simple one, not that much lengthy. So again as usual we start here. What is the starting? As you don't know about the tangent equation, we start with y equal to mx plus c. Okay, so y is mx plus c, we start here. Then what is equation for parabola? Y square is 8ax, that is 4 into 2a into x. Okay students, so the parabola is of this form. Now let us take the tangent as here y is mx plus c. This is our tangent equation. Okay, now once it is a tangent equation, what is our formula? C is a by m. Here in place of a you are having 2a. So y equal to mx plus c means 2a divided by m, right? And now this is even tangent to what? Circle also. Okay, first this one is here tangent to which one we have taken? Parabola. Y square equal to 8ax condition we have applied. But this line is tangent to which one also? Is tangent to circle also. That is x square plus y square is 2a square. This also. Now all of you remember the condition. Whenever y equal to suppose mx plus c is tangent to a circle, that is x square plus y square is r square. What is our condition? C square equal to r square into 1 plus m square. So this is our condition, or you can make use of d equal to r. Now here I am making use of this condition directly. C square. What is our c square, students? This is our c, right? So c square means what is the value? 4a square by m square and equal to r square. R square you are having here 2a square and into 1 plus how much we are writing? M square. Okay. Now let's cancel here 2a square. Here 2 value you got. Now if I do cross multiplication, this is equal to 2 equal to m square plus m to the power of 4. That implies you got the quadratic, the biquadratic m power 4 plus m square minus 2 is 0. Okay. Now if you solve the equation, the roots are m square plus 2 and into m square minus 1 is equal to 0. Understand all of you? This is plus 2m square minus m square. Hence m square plus 2 not 0 implies what are our roots here? M is plus or minus 1. So the m values you got 2 values. That's why we got here 2 kinds of common tangents. Now let us substitute that m value 1 here, then y equal to x plus 2a. So one tangent, students, we can consider y equal to x plus 2a and the other tangent we can consider as how much here? Y is minus x minus 2a. So these are finally the 2 tangents which are for circle as well as parabola. Okay.